Hello students, welcome to my channel Positron. Today's topic is, dear students, acceleration. Dear students, in last my video, I have discussed with you all about the velocity and the speed. Before that, I have discussed with you all the distance and displacement. And today's topic is acceleration. Acceleration is what? That is rate of change of velocity. Velocity covered in 1 second is called to be the acceleration. You can say that A is equal to acceleration. A is equal to delta V upon delta T. That is delta V upon delta T. The rate of change of velocity, that is said to be the acceleration. Now, dear students, in general, what we do, we consider the instantaneous acceleration. Instantaneous acceleration means velocity at a particular moment or velocity at a particular instant is said to be the instantaneous acceleration. That is expressed as A is equal to limit delta t tends to 0 delta V over delta t. That is A is equal to limit delta t tends to 0 delta V over delta t. It is representing actually the instantaneous acceleration. Dear students, in last of my video I have told you all that limit delta t tends to 0 is what? Means time difference is approaching to 0 but not 0. It is infinitesimally small. A is equal to limit delta t tends to 0 delta V upon delta t. To this expression you might write A is equal to dV upon dt. This is the acceleration actually. Dear students, the part of your syllabus considers the constant acceleration. In this part of physics, you have not to consider the varying acceleration. The rate of change of acceleration is called to be the jerk, and that is not the part of your syllabus. I'm sure and damn confident that you know the equations of motion. The three equations of motion are actually V is equal to U plus AT, S equal to UT plus half AT square, and V square equal to U square plus 2S. Actually, all these equations considering the constant acceleration. Dear students, I have told you that acceleration is a rate of change of velocity. As you know, dy upon dx is what? If dy upon dx is actually dy upon, dear student, dy upon dx is a change in y with respect to x. Means y is a function of x. If y is a function of x, then dy upon dx means what is means of differentiation? Dy upon dx means you are differentiating y with respect to x. And if y is equal to a bit primary, the basics you should know, only then you can. Dear student, my first video I have told you all that physics has the three basic instruments. If you want to have good physics, deep physics, then the three instruments you have to know about. The first is a vector analysis, you have to be master of that. Second one is a graphical analysis, that every equation you can make the graph, you can realize that equation with the graph. And third one is a very important, one of the most important tool to study the physics, and that is the calculus, integral and differential. So as soon as we need, I will try to describe you. Dear student, if y is equal to x to the power n, then dy dx, rather why I am writing x to the power n, that is equal to nx to the power n minus 1. Dear student, let's discuss what is dy upon dx. dy upon dx is, it means you are differentiating y with respect to x, means y is varying with respect to x. Y is a function of x. dy upon dx also means if a graph is plotted between y and x like so, then at any point dy upon dx is the slope of tangent drawn at that point, this slope. So let it is a point P, it is a y, this is x, then dy upon dx at point P is equal to, that is m, that is tan theta. tan theta. Dear student, dy upon dx at a point P means slope of the tangent drawn at point P. Now, dear students, as I have said that acceleration is a rate of change of velocity dv upon dt. It means if a graph is given between velocity and time, then you have to find out the slope of that graph that will represent the acceleration. Dear student, okay, just I have said that if the graph is given between velocity and time, then the slope of the graph will represent the acceleration. Dear students, if the graph is given between the displacement and time, then how will you find out the acceleration? Then if it is between displacement and time, then you have to draw the graph following that graph between displacement time. You have to draw between velocity and time according to the displacement and time graph, and then you can find out the acceleration. Just after that we are going to discuss. Now ds and dy upon dx, if dy upon dx is a positive, it means y is increasing with respect to x. If dy upon dx is negative, negative means y is decreasing with respect to x. And if dy upon dx is equal to 0, means y equal to constant. It means y is independent of x. In similar way, you can say dv upon dt is a positive. If dv upon dt is positive, means velocity is increasing with respect to time. It is acceleration. If dv upon dt is negative, it means velocity is decreasing with respect to time, and it is retardation. And if dv upon dt equal to 0, then v is equal to constant, means body is moving with constant velocity, and that is said to be the uniform motion. Body is under the uniform motion. Now dear students, I try to let you understand acceleration. Today's topic is one and only one, that is the acceleration, and after that we will discuss the equation of motion. Again I am coming back to the topic. Dear student, what I have said that acceleration is a dv upon dt, rate of change of velocity is called to be the acceleration. Just I am repeating my words. I have said that if the graph is between the velocity and time, then slope of that graph at any instant represent the acceleration. Like you can say, let it is a graph between velocity and time, and at this point you have to find the acceleration. Then I have drawn the tangent at this point, a line parallel to the x-axis, and now take the slope. This is and this is clockwise. So a is equal to dv upon dt, and that is equal to m, and that is equal to tan of minus theta, dash minus tan theta. This slope is negative, means acceleration is negative, means it is a retardation, means velocity is decreasing. Okay, dear students, in this case acceleration is negative, means it is a retardation. It means velocity is decreasing. Dear student, it was between the velocity and time graph. With the help of that graph, we tries to find the acceleration. Now again, let between the velocity, dear student, between graph I am considering three, four graphs. It is between the displacement and time. And now consider what the acceleration is in these cases. First is that one, second one is that one, third one is that one, and fourth one is that one. Four graphs I have considered. That is the graph between the displacement and time. First one is that, second one is that, third one is that, the fourth one is that. Let it is graph A, this is graph B, this is graph C, this is graph D. Dear student, you know this graph, we have to find out the acceleration, but actually it is a graph between the displacement and time. With the displacement time graph, directly you can find the velocity, but acceleration you cannot. So how will we find out acceleration? Dear student, let us consider the first graph. It is these graphs are between s and t. So slope of the graph at any instant represent the velocity. these graphs are between displacement and time. So slope at any instant represent the velocity. So look here, I am considering 3 points here. At this point slope is that, at this point tangent is that, at this point tangent is that. Look here, ds it is anti-clockwise theta, and this is parallel to x-axis, so theta equal to 0. And look here, here it is clockwise, so theta will be negative. So ds m is equal to tan theta. So here the velocity is positive, because it is a graph between displacement and time. I am repeating my words. I am just again and again telling you that if the graph is between the displacement and time, then slope will represent the tangent, will represent the velocity ds upon dt. If the graph is between velocity and time, then tangent at any instant will represent dv upon dt. I mean the acceleration. Now dear student, at this point slope of the tangent is positive, so velocity is positive. At this point slope of the tangent is parallel to x-axis, so it is 0. So velocity will be 0. V is equal to m equal to tan theta, and here slope is negative, means velocity is negative. Now dear student, how do we describe? We have to analyze that. Here at this instant velocity was positive, then becomes 0, then becomes negative. Velocity was positive, then becomes 0, and then becomes negative, means velocity is decreasing. And if the velocity is decreasing, that is a retardation, means a is equal to negative. It is a retardation. This is the good example of this graph, retardation. Yet the graph is between the displacement and time, but it is representing actually the retardation. Now dear students, second graph, again it is between the s and t. Consider the 3 points. 3 points, how do we consider? Not a one side. Actually this graph has a three nature. Once decreasing, then approximately at minimum position, and then increasing. So the 3 points we are considering at three positions, at three conditions. First, when decreasing, when it is a minimum, and third, when it is increasing. Now dear student, at this point tangent of the slope is negative, so velocity is negative. At this point tangent of the slope is parallel to x-axis, so theta equal to 0. So v is equal to m equal to tan theta equal to 0, so velocity is equal to 0. At this instant dear student, so it is anti-clockwise, so theta is positive, and if theta is positive, it is graph between displacement and time, so velocity will be positive. Now dear student, look here, interesting. Initially it was negative velocity, then become 0, then positive, means velocity is increasing. And if velocity is increasing, then it is acceleration is a positive, means increasing velocity, it is motion is accelerating. And let us consider the third case. Third case is what? Now dear student, between s and t the graph is a straight line. Both the graphs are a straight line, but this is the inclined one and this is parallel to the x-axis. Dear students, in this case take 2 points. Draw the perpendiculars on ordinate and abscissa. Now look here, at this point T1 and T2, the displacement is the same. Means let a body is kept at t equal to 0, body is kept 20 meter away from the origin, and as gone with the time increases, but the displacement is not increasing or not decreasing. It means body is at rest. So body is at rest. It means if body is at rest, then velocity is equal to 0, acceleration is equal to 0. So if you have to draw, according to this, you have to draw the velocity time and acceleration time graph following this graph between the displacement and time. So velocity time will be like will be this, and even acceleration time will be like this because both are 0. Is it? Now, dear student, the last D is a very important. The fourth graph. Now look here. This is a graph between S and T, displacement and time. The graph is an inclined one, slant. So, if the graph is straight line and inclined, so it means S is proportional to T, dear student. So, S is proportional to S is equal to K2. In order to remove the proportionality, you have to multiply with a constant. Differentiate with respect to t, so it will become ds upon dt, that is equal to k is a constant, you can take out ds and k I have taken out d by dt of t, and that is d by dt of t is equal to 1, so ds upon dt, ds becomes k, or velocity is equal to k. Now it means velocity is a constant, and if velocity is a constant, then a is equal to dv upon dt, and that is equal to d by dt of k, and differentiation of a constant is 0, so equal to 0, so acceleration is 0. So again, just a minute before you have plotted the graph between acceleration and time, it is acceleration is equal to 0. This kind of graph will it be. This, according to this third and fourth graph, neither the body is accelerating nor retarding. Now dear student, in last of my video I have told you if the graph is plotted between velocity and time, then the area covered between graph and x-axis represent either the distance or displacement. If you consider the sign, then it is a displacement, and if you do not consider the sign, then it is a distance. Dear student, let a graph is plotted between acceleration and time, and it is like so. Let, dear student, a graph is plotted between acceleration and time, it is like so. I told you that if the graph is between velocity and time, then acceleration is what, dv upon dt, means you have to differentiate the velocity with respect to time, and if the graph is between velocity and time, then acceleration is dv upon dt, means it is the slope of the tangent drawn on a graph between velocity and time. If the graph is like so, between velocity and time, at this point, this is let point P, it is point Q, it is point R. At this point, if you have to find out the acceleration, then what you have to do? You have to draw the tangents at this point, and now find out the slope of tangent. How will you find out the slope of tangent? From the points, draw a line parallel to x-axis from these points, like so, like so, like so, and now from x-axis the angle it makes, let it is theta 1. So here the acceleration a1 is equal to dv upon dt, that is m, that is equal to tan theta 1, and here it is clockwise actually. So m is equal to a is equal to m equal to tan minus theta 2 or minus tan theta 2. So you can say it is a retardation, and similarly this is also retardation because it is also clockwise. Dear student, this was a condition when the graph was given between velocity and time, then finding just the slope of the tangent at a point you can find the acceleration. But what happens if the graph is given between acceleration and time, and you have to find out with the help of that graph the velocity. Dear student, acceleration is a vector quantity, so and velocity is also a vector quantity. Now dear student, it is a graph between acceleration and time. Dear students, if you have to find out the velocity, then you have to find out the covered area between the graph and x-axis. It is a graph and this is the x-axis. Covered area between graph and x-axis means this area plus this area. If you consider these areas positive, means you are not considering the sign at all, then it will turn into the velocity. Graph between x-axis, area between graph and x-axis. if the graph is plotted between acceleration and time, then the area, just by not considering the sign, it will represent the speed. But if you consider the sign, then it will represent the velocity. Dear student, let it is a 10, this one is a minus 10, it is 1 second, and this is 2 seconds. It is meter per second square. Now, velocity will be what? It is 10, this is a rectangle, so length into breadth, 10 into 1. And now consider the sign. It is actually velocity I am finding. This one is a 10 into 2 minus 1, 2 minus 1, this base. It is actually a right angle triangle. So area of this will be 1 by 2, base into height by 2. So it is 10 minus 5, that is 5 meter per second. The area between graph graph of the area between acceleration and time graph represent either the velocity or speed. If you consider the sign, then it is a velocity, and if you do not consider the sign, then it turns into speed. Now dear student, speed will be, this is, again this area is 10 and this area is 5, take plus 5, this is 15 meter per second. The one inequality you should know, the distance is either greater or equal than displacement. In similar way, speed is either greater or equal than the velocity. So dear student, finally I would like to say that if the graph is given between acceleration and time, then covered area of the graph between graph and x-axis represents either velocity or speed. If you consider the sign, then it is a velocity, and if you do not consider the sign, then it is a speed. Now dear students, I hope my videos are working to you. It is going to be beneficial to you. It will enhance your knowledge. If you think so, then please like, share and subscribe my videos and put the bell icon so that you can get the information about my next video. My next video undoubtedly just within 1 or 2 days, it would be about equations of motion and all the 3 equations that we have to graph them. And after that, the next video will be one of the most important videos related to the mechanics, and that would be on the relative velocity. Till then, bye. Have you all a very good day ahead.